I have quite a collection of stainless steel cups here, and there are plenty of great ideas I want to try with them. Instead of squeezing everything into a single video, I'll turn them into a series, with each video featuring a different project. In this episode, I'll start by building a simple antenna device using a stainless steel cup. First, let's mark 2 drilling points just below the bottom of the cup to make the assembly process easier later on. Here are 2 sets of bolts and nuts with metal washers. I chose them with suitable threads to fit securely into the 2 holes drilled beneath the cup. They not only hold the parts together firmly but also serve as the signal receiving elements of the device. These 2 single-core wires I prepared here will act as the connection between the components, linking the parts together securely. This ensures the signal can pass through smoothly without any concerns. One end of each wire has already been connected to the signal receiving router. And to route the other 2 wire ends out of the cup, I will drill 2 holes directly into the stainless steel cup to create proper passages for the wires. This is a roll of aluminum foil. Far beyond its common everyday uses, in this setup it plays a crucial role as the primary signal receiving element of the router assembly. When crumpled into 2 solid cores and attached to both ends of the previously installed router shaft, it becomes a key component that enhances signal capture and transmission stability, helping the entire system operate more reliably and efficiently. A good antenna base needs to be solid and should not cause signal interference. Therefore, materials like wood or plastic can be used for the base, as long as they provide enough stability for the overall structure. Use hot glue to fix the rim of the stainless steel cup to the underside of the base. This is a very convenient and useful method, especially when you understand how this type of glue helps hold the parts firmly while still allowing easy handling. Next, I have a positive electrical plug which I will connect to the other end of the two wires, making assembly and connection easier later. The signal transmission section of the antenna assembly begins with a female plug connector, which serves as the first connection point of the assembly. This is a coaxial cable, an essential part of the signal transmission section. I'll connect one end of it to the female plug connector, while the other end will be prepared later for connection to the TV. This is a female F connector. One end will be connected to the coaxial cable, and the other end will be fitted with an additional 90-degree F connector. This is the 90-degree F connector I mentioned earlier. This feature makes connecting to a TV easier in locations with limited space, and also allows for neater cable management without excessive bending. Before we begin the test, let's verify something first. At the moment, the TV is still showing no signal because the antenna has not been connected yet. I want to show this beforehand so the test results can be seen more clearly and objectively. Let's not jump to conclusions just yet. Although the screen is already displaying an image, we should wait a little longer. After that, I'll disconnect and reconnect the setup, then test it again to make sure the result is truly reliable. And so, from very familiar items like a stainless steel cup and a piece of aluminum foil, we've created a structure with a completely new purpose. What truly matters is not their original value, but how we observe, think, and reuse what is already around us. Sometimes, even a small idea born from repurposing can open the door to new directions that are more efficient and far more creative. And who knows, out of the most ordinary objects, we might discover the most surprising and interesting solutions for our next projects.